In this video, we will see the vector scan and raster scan display. Before looking for this raster scan and vector scan display, these are the two techniques which are to be used to produce an image on the CRT screen. And that's why, first of all, we will see the vector scan display. As we can see the image over here, so in this vector scan, the CRT display directly traces out only the desired lines on the CRT screen. It means if I want to draw a line connecting the point A with point B on the vector graphics display, so we simply drive the electron beam, so which will cause this beam to go directly from point A to point B. And if I want to move the beam from point A to point B without showing a line between these 2 points, then we can blank the beam as we move from point A to point B. So to move the beam across these points, across the CRT screen, so the information about the magnitude and the direction is required. And this information is generated with the help of vector graphics generator. Now, this is the figure which shows the architecture of vector display. In this diagram, we can see a display controller, a central processing unit, display buffer memory, and the CRT screen. So here, a display controller, it is connected to the input-output peripherals to the central processing unit. And the display buffer memory is here. It stores the display program. So this display program, it contains the point and the line plotting commands. So this display controller, it interprets the commands for plotting the points, lines and the characters, and it sends the digital and the point coordinates to the vector generator, whereas the vector generator converts the digital coordinate values to the analog voltage for the beam deflection on the CRT screen. So in this way, this vector display works. In vector display, the beam is deflected from the end point to the end point, and hence such technique is called as a random scan display. So as we know that the beam strikes on the screen, so the phosphor emits the light, but phosphor light decays after few milliseconds, and therefore it is necessary to repeat through the display list, to repeat through the display program, to refresh the phosphor at least 30 times per second, so to avoid the flicker. So as this display buffer, it is used to store the display program and it is used for refreshing. So the display buffer is also called as a refresh buffer. Now we will move to the raster scan display. Now here you can see the architecture of the raster display, and this raster display architecture consists of the display controller, video monitor, central processing unit, the refresh buffer, keyboard, mouse, and the CRT screen. In this figure, the display image is stored in the form of the zeros and ones. So the video controller, it reads this refresh buffer and it produces the actual image on the CRT screen. So it does this by scanning one scan line at a time. So it does this by scanning one scan line at a time. So here in this raster scan, the most common method is to display image on the CRT screen. So in this method, the horizontal and the vertical deflection signals are generated to move the beam all over the screen in a pattern. So here we can see that when the beam is moved from left to the right, the beam is on. And when the beam is moved from right to the left, which is to be shown in the dotted line, at that time the beam is off. Now when the beam reaches, in this way, when the beam reaches to the bottom of the screen, it is again made off and it is rapidly retraced back to the top of the screen. So a display produced in this way is called as a raster scan display. So raster scanning process, it is similar to the reading different lines on the page of a book. So after completion of this scanning, scanning of one line, the electron beam flies back to the start of the next line and the process repeats. So in raster scan display, the screen image is maintained by repeatedly scanning the same image. So that is called as a refreshing of the screen. So the special area of memory is dedicated to the graphics. It's called as a memory area. That is that memory area is called as a frame buffer, and it holds the set of intensity values for the screen points. So that stored intensity values are retrieved from the frame buffer and displayed on the screen. So the screen point, it is called as a pixel or a pale. So a frame buffer with 1 bit per pixel is called as a bitmap. It is called as a bitmap, and the frame buffer with multiple bits per pixel, it's called pixmap. Now here is the difference between the vector scan and the raster scan display. So in vector scan display, the beam is moved between the two endpoints or between the endpoints of the graphics primitives, as we have seen in the diagrams initially. And in the raster scan display, the beam is moved all over the screen, one scan line at a time, from the top to the bottom and then back to the top. So in vector display, the flicker comes when there is the large number of the primitives. But in vector display, in a raster display, the refresh process is independent of the complexity of the image. Whereas the scan conversion is not required in the vector scan display, and in raster scan display, the scan conversion is required. The scan conversion is required. Whereas the scan conversion hardware is not required in the vector scan display, but in raster scan display, the scan conversion hardware is required to for the each primitive, as it is needed to convert as it is needed to be scan converted. And next is a vector display draws the continuous and smooth lines, whereas the raster display can display the mathematically smooth lines, polygons, and the boundaries of a curved primitives. Cost is more in for the vector scan display. For the raster scan display, the cost is low. And in a vector scan display, the vector display only draws the lines and the characters, whereas for the raster display, it has the ability to display the areas filled with the solid colors or the patterns. This raster scan display, it is majorly used for the to develop the realistic scenes. So this is about the raster and vector scan display and its differences. Thank you.